Welcome back to educator.com. Today we're going to continue our focus on market structures with a particular emphasis on monopoly and monopoly graphs. So today's lesson overview, we're going to review the characteristics of a monopoly. We're going to differentiate between the demand curve of an individual perfectly competitive producer versus the demand curve of a monopolist. We're going to define price discrimination, what exactly price discrimination is, and correctly draw the components of a monopoly graph with the demand curve, marginal revenue, ATC, MC, equilibrium price and quantity, deadweight loss, making profit, incurring loss, and also breaking even. Finally, or second to last year, we're going to compare monopoly versus perfect competition in terms of allocative efficiency. And also, we're going to understand elasticity of demand on the demand curve and its impact on total revenue. So product markets. So we're still on this huge section on product markets. Now, as a reminder, this is 55 to 70% of your AP exam. So this is a huge portion of the AP exam, and consequently a large focus of these lectures cater towards understanding the product markets. So this portion here is going to cover understand the relationship between a monopolist's demand curve and its marginal revenue curve. Students learn how a monopolist's total revenue curve changes along his demand curve as price varies. Students should compare a monopolist price, level of output, and profit with those of a firm operating in a perfectly competitive market. By paying particular attention to the concept of allocative efficiency. What is this allocative efficiency? Students should learn how and why competitive markets achieve an efficient allocation of resources, whereas monopolists do not. Monopolists are not allocatively efficient. The concept of deadweight loss is a good device to show the efficiency loss due to monopoly. The model of price discrimination provides another dimension of monopoly behavior that students need to learn and understand. So basically, there are a lot of different parts of monopoly. I've actually broken down monopoly into two separate lectures. The first one here, the basics of monopoly. The second lecture is going to be monopoly and public policy. So what are the characteristics of a monopoly? What are things that make a monopoly? Well, we do know that a monopolist is the only producer, hence there's only one seller of a good with no close substitutes. And it tends to have at least, sometimes more, one of these four barriers to entry. The first barrier to entry is the control of a scarce resource or input. Cecil Rhodes made De Beers what it is by controlling most of the world's diamond mines. If you're the only one producing that product, you're well poised to dominate that particular market. Economies of scale. So there's certain industries where it's better for only one firm to produce. So large firms tend to have cost advantages in markets characterized by economies of scale or a natural monopoly. So natural monopoly, it's just better for there to be one seller. For example, trash services is if one firm controls the trash pickup for the entire neighborhood, chances are the average total cost is going to be cheaper than if you have 5 or 6 different trash services competing in the same neighborhood. So that would be an example of maybe economies of scale or natural monopoly. Another very simple thing is technological superiority. So short-term advantage for companies, although network externalities are very crucial as well. So for example, Microsoft Word might not have been the best particular product out there on the market. However, as more and more users started using Microsoft, it's actually network externalities that caused Microsoft to become what it is today. So it's not necessarily a long-term advantage for technological superiority, but it definitely does help for a firm to have technological superiority in order to have a monopoly. And the last type of monopoly is actually a government monopoly, and this one is fairly self-explanatory. So, for example, a patent, which is a monopoly of invention. So if you create something, you create a patent for it. Or a copyright, which is a monopoly of literary or artwork. So if the government grants a monopoly, then it is the only entity that can actually produce that particular product. So monopoly and price discrimination. So generally speaking, when the case is made for price discrimination, usually it's actually third-degree price discrimination. What is third-degree price discrimination? Third-degree price discrimination is a policy of charging different prices to different customers or consumers for the same good. For example, movie tickets. Senior citizens get a different rate. Students get a different rate. The whole idea is that you charge higher prices to individuals that are willing to pay higher for a movie. So presumably a full-grown adult, 35 years old, is willing to pay $12 for a movie ticket, whereas a high school student might only want to pay $9 for a ticket. So that's an example of price discrimination in regards to movie tickets. Rebates. There may be plenty of people out there that's willing to pay $100 for a computer. Now, the manufacturer, the seller of the computer, may prefer to sell it at $100, but equally okay with selling the computer at $70. So what's the best way to target both markets? Well, you sell the computer for $100, but you also attach a $30 rebate if you send in a rebate. And chances are not everyone is going to actually send in that rebate. So there's some price discrimination there. And for airline flights, business consumers will tend to pay higher prices for airline flights, whereas vacationers will actually pay lower prices. Now, when you buy an airline ticket, they're not going to ask you, are you traveling for pleasure or traveling for business? Usually time is the best function to determine if one is a business traveler or a vacation traveler. The closer to the flight, chances are that you have a business traveler. And then further away from the flight, chances are you're a vacation planner. Now, obviously, there are different exceptions and rules, but for the most part, there are ways that airlines can price discriminate. Another policy that some airlines have is policy of overbooking. And once they overbook, they will provide incentives for certain people to decide not to fly on that particular flight. And again, it's usually the vacationers that are willing to kind of bend. And so they're basically ending up paying a lower price for a particular flight in general. And so first degree or perfect price discrimination, it's a very interesting concept. It's not something that any company, to my knowledge, has the ability to do. But again, it's actually a pretty fun construct to actually think of. What is perfect price discrimination? It takes place when a monopolist charges each consumer his or her willingness to pay, the maximum that the consumer is willing to pay. So if a consumer is willing to pay $10, a monopolist charges $10. If a consumer is willing to pay $4, the monopolist charges $4. So let's take a look at how that would look like on a monopoly graph here. So let's call this the demand curve. Here's the quantity and here's the price. And let's say here's the market price. Let's say it's $5. And let's say this is 4 products. So one person is willing to pay, let's say, $9. The second person is willing to pay $8. And the third person is willing to pay $7. So in terms of the market pricing, if the market price were right here, the consumer surplus would be this area here. The price above the market, but below the demand curve. So when a monopolist comes in and practices perfect price discrimination, he basically goes to that consumer and charges $9 here, charges $8 to the second consumer, charges $3 to the third consumer, or charges $7 to the third consumer, $8 to the second consumer, and then charges $5 to the fourth consumer. Now, is the monopolist ripping off the consumers? From an economic standpoint, absolutely not, because the consumer was willing to pay that price, but the monopolist was able to capture that entire amount. Now, in terms of consumer surplus, the amount of consumer surplus that's lost, well, let's take a look here. So 9 minus 5, so that's 4. So there's a negative 4. That 4 consumer surplus area is gone. 8 minus 5. 8 minus 5. You have 3. 7 minus 5 equals 2. And then the fourth consumer, because he was only willing to pay $5, there's no consumer surplus that's lost. But basically, 9 consumer surplus is lost in this particular case where there's only 4 individuals. So what perfect price discrimination does, it takes away any extra utility and extra happiness that a consumer would get from buying at a lower price than he otherwise would have paid. So he's no longer extra happy. So if companies actually had this power, they would love it if they could pick inside an individual's brain to figure out exactly how much he or she is willing to pay. But as far as I'm aware, there's no specific mechanism that companies can do this with 100% accuracy. Now, companies spend millions and millions of dollars trying to find ways that they can market out to different groups of people and charge corresponding prices, but it's really difficult to look into each individual's willingness to pay. It's going to vary. And so this is, again, kind of an interesting thought experiment. So let's take a look at an actual monopoly making a profit and be able to draw the graph here. One example of monopoly making profit here is perhaps, let's take a look at an electricity company. Let's say this electricity company might be the only electricity company in the town, and let's say it's unregulated and it's trying to determine how much electricity should we produce. And again, companies are selfish, and assuming that there's no government regulation and they could do what they want, the terminology might be an unregulated monopoly. They're going to operate quite differently than a perfectly competitive firm here. So first things first here, you want to label the price, and you want to label the quantity here. And then the demand curve, the downward sloping line, and you label it D. And you also want to draw the marginal revenue curve. And one thing I like doing here, when you cross the marginal revenue curve with the x-axis, you want to label that as MR equals 0, because that's going to be a point of revenue maximization. Now, this is not going to be a central component of drawing a monopoly graph, but it's good to have that point in there so that when you come into later problems with elasticity, that point is actually going to be quite essential here. But let's just take a look at this here. What is the relationship? I'm going to write this down here. What is the relationship between demand and marginal revenue in a monopoly? It's actually quite simple, and sometimes I think students might tend to overthink the question. They know the answer, but they want to say something really fancy, so they might leave it blank. But the simple answer is that the marginal revenue is below the demand curve, and it's steeper than the demand curve. So this would actually give you credit. On the actual AP exam, this is one of the questions that came up. What is the relationship between demand and marginal revenue in monopoly? And I think many students may have gotten this wrong because they overthought the question. So the marginal revenue is below the demand curve and steeper than the demand curve. So that's the relationship. And this is the monopolist dilemma. As they try to sell more and more because they control the entire market for that particular product, as they sell more and more, the marginal revenue decreases at a greater rate. So for example, let's use a crude example. Let's say you're selling one item for $10. And a monopolist is going to get a total revenue of $10. Because total revenue equals the price times the quantity. Well, if a monopolist sells that second item, let's say the market price is actually $8. Okay. Well, the problem is not only are you selling the second product for $8, you're also now selling the first product for $8 as well. So you lose $2 per item that you sell. So the total revenue here is going to be equal to 16. Okay, so basically what you have here is the marginal revenue here is going to be 10 for the first item, but the marginal revenue for the second item is now 6. Okay, and let's take a look at a third item. Let's say the third item is now only $6. Now you're in trouble. Now not only do you drop $2 for the third item, you drop $2 for the other two items. So 3 times 6 is now equal to 18, and your marginal revenue now equals 2. So if you continue this trend, you can actually see the relationship between the demand curve and the marginal revenue curve until at a certain point, the marginal revenue might actually be negative. And so that's kind of an in-depth look at the demand curve and the marginal revenue curve here. The next curve that you want to draw when you plot these points out is the marginal cost curve here. So how do you draw a marginal cost curve? You just do it. You just do it, just like the Nike sign. You just do it. So there's the marginal cost curve. And again, you have the marginal cost and your marginal revenue and marginal cost curve. What is the profit maximizing rule? The profit maximizing output is where the marginal cost equals marginal revenue. So label this as Q star here. Now, a common mistake that some students will make is that they're going to put the profit maximizing quantity right here. But the problem here is the monopolist would be being way too nice, charging where the marginal cost and the marginal revenue intersect. Now that's the quantity that they produce, but they want to maximize. Everything that they can. I'm sure consumers would be happy to buy at this price, but they're going to charge where the marginal cost and the marginal revenue meet, but they're going to charge the price where it hits the demand curve. So this is the optimal price, and you have the optimal quantity. Okay. Now the last curve that we're going to draw in here is actually the ATC, or the average total cost. And there's really no magic or no rule specifically where you can draw the ATC, as long as you understand that the price is going to be greater than the ATC, because if the ATC is greater, then you have a monopoly incurring a loss. So a good rule of thumb here is choose any point along the marginal cost curve between the marginal revenue and demand curve. And I like choosing somewhere in the middle, and you draw a dot in there, and you draw a smiley face, the average total cost. Because what do we know? We know that the ATC and the MC intersect at the minimum point of the ATC. So that's kind of a good rule of thumb right there. And what you see here is you have the ATC, and it's going in between the demand curve and the marginal revenue curve. Now the last part of figuring out where the economic profit here is where the price and quantity meet. This is going to be the total revenue here. So this huge rectangular area is going to be the total revenue. Now where's the total cost? Well, the total cost is going to be where the ATC and the quantity are going to be in this rectangular area. So the profit is the difference between the two. So if I can map that out, profit equals the total revenue minus total cost. Now, how do you actually find the total revenue? The total revenue is the price times quantity. And you subtract the total cost. And what is the total cost? It is the ATC times the quantity. So if you actually work this out, price times quantity minus ATC minus ATC minus Q, you're going to have, or the minus ATC times the quantity again. What you're going to have here is that this area here is going to be the economic profit. So you take this, you subtract this area, and your economic profit, labeled in green, is going to be the area of economic profit. And this is sustainable in the long run because there is economic profit in a monopoly, whereas in a perfect competition, there is no economic profit in the long run. Now, in the short run, a monopoly can also incur a loss. And this is actually how it would be. Very similar to a monopoly making a profit, except where you draw the cost curves will obviously differ. So you have a demand curve right here, quantity, and you have the price, and you draw the marginal revenue, which is below the marginal, below the demand curve here, and this is the marginal revenue, and you want to label MR equals 0, where it crosses the x-axis, and you just do it, marginal cost, and then the ATC is going to be between the demand and marginal revenue, the minimum point, and you go ahead and draw the ATC here. Now, where's the profit maximizing quantity? It's where the marginal cost and marginal revenue intersect. And this is the profit maximizing quantity. You move up until it hits the demand curve, and you have the profit maximizing price here. Now, where is the economic loss? Oh, okay. So I actually made a mistake, but this is if you're looking at this and you kind of understand what you're doing, then you realize the mistake. And if you notice, what I did was I drew the ATC below the demand curve here. So I'm going to go ahead and erase this ATC. Redraw some of the elements here. So I'm going to redraw the ATC. So if you want to make a profit, then you go in between. But if you want to incur a loss, then what you do is you take a look at the marginal cost curve, and along the marginal cost curve, but above the demand curve, that's where you want to draw the ATC. So you go like this, ATC. And keep in mind, the marginal cost and the ATC intersect at the minimum point for the ATC. And now the economic loss is going to be below the ATC, let's use red, but above the price. So here would be the economic loss. So it's the same thing, same formula. Profit equals total revenue minus total cost. And in this case, the total revenue is going to be the price times the quantity minus the ATC times the quantity. Now what's going to end up happening is that the ATC is greater, so you're going to get a negative profit, so it's a loss. So negative economic profit is going to be an economic loss. All right, so let's compare a monopoly versus perfect competition in terms of allocative efficiency. So in a perfectly competitive market, price equals marginal cost at the perfectly competitive firm's profit maximizing quantity of output. So price equals marginal cost. Now in a monopoly, things are different here. Price is greater than marginal revenue equals marginal cost at the monopolist profit maximizing quantity of output. So you're going to have a different situation where a monopolist is going to produce where the price is greater. Okay, so a monopoly charges a higher price, produces a lower quantity, and earns a profit, which are all things that in perfectly competition is not going to happen. In perfect competition, there's a lower price, higher output, and there's no economic profit. In other words, a monopoly is not allocatively efficient because it does not produce where the price equals the marginal cost. So let's take a look at a perfectly competitive market versus a monopoly. So here's Mr. Part. So here's the price, or the quantity and the price, and this is Mr. Part. The marginal revenue equals price equals average revenue equals demand. And here's the marginal cost. And just for good measure here, here's the ATC. This is in a long run equilibrium, the ATC. Well, guess what? This point is serves as actually 2 points here. So this is a point of productive efficiency. Why is it productive efficiency? The price and the price equals where the minimum of the ATC is also produced. So it's productively efficient. But more common to that, more central to that, is this is also the point of allocative efficiency. So this point right there is also Q star here and P star, because the price equals the marginal cost here. Price equals the marginal cost. So that's perfect competition. So nothing new. This is a review here. Now, how does a monopoly actually look here? So you have the demand curve here. And again, you have the marginal revenue curve that intersects the x-axis here. So MR. So right here, MR equals 0. And here's the marginal cost. And then the ATC is shown right here. And again, you want the profit maximizing quantity of output and the profit maximizing price. All right, so where's the allocatively efficient point? So I'm going to label this as where the price equals the marginal cost curve. So this is going to be QS, allocated efficiency. So notice here, so this is PS. So the price that the monopolist charges, which is P star versus PS, the allocated efficient price, you get the higher price. The monopoly charges a higher price. And here, the monopoly chooses to produce a Q star or an allocatively efficient, they charge QS. And QS or Q star is less than QS. So a monopoly produces a lower quantity. Okay. And it earns a profit. So right here, this is the economic profit here. Whereas in perfect competition, you see that there is no profit here. So a monopoly is not allocatively efficient. Now, another way to say that a monopoly is not allocatively efficient, another way, it creates deadweight loss. So this area here is deadweight loss. So that's one way to describe how a monopoly is not allocatively efficient. A third way of describing that it's not allocatively efficient is there does not exist maximum consumer and producer surplus. Kind of an awkward way of phrasing it, but if it was allocatively efficient, you would maximize consumer and producer surplus. But since it doesn't, then you basically lose some surplus, either on the consumer or producer side. So let's actually read a monopoly graph and go through a variety of situations and a variety of points, because sometimes you're going to be required to draw monopoly graphs. Other times, you're going to be required to be able to read a monopoly graph with the information that's given. So let's look over this example here. Let's assume that there's only one stadium in Parkville, and the stadium's demand and cost curves are shown above. The stadium currently relies on an admissions charge for its revenue. So let's take a look at different charges, different price points, and see what points would satisfy certain requirements here. And again, you have the standard demand curve, you have the marginal revenue curve intersecting the x-axis, and you have a variety of different prices and quantities where the average total cost and the marginal cost intersect here. But again, taking a look at this graph here, you know the relationship of the marginal revenue and the demand curve. The marginal revenue is steeper and below the demand curve. The marginal cost is just like a Nike sign, just do it. And the average total cost curve is drawn in between the marginal revenue and demand curve. So again, this might look fairly complicated with a lot of points intersecting, but if you break it down one by one, then this is very easily drawn. All right, so using the labeling of the graph above, identify the price and quantity that maximizes profit. All right, so this is going to figure out for attendance at this particular stadium. You want to always stop where the marginal cost equals the marginal revenue. So this is the rule here where MR equals MC. So you want to produce at this quantity, Q2. So Q2 would be the profit maximizing quantity, but that's only half the answer. You want to run this up to the demand curve here, and you get P5 here. So what is the profit maximizing price? You have Q2 and P5. Now, using the labeling on the graph above, identify the price and quantity that maximizes total revenue. So I've gone over this before, and here's the reason why. You want to move the marginal revenue all the way down through the x-axis, because that is the point of revenue maximization. Because think about it, if the marginal revenue is positive, then anytime it's positive, you're gaining more revenue. Here, you go into the negative territory, and you're actually losing money on the margin. You could still be profitable, but you're losing money on the margin here. So what maximizes total revenue? Well, it's when it intersects the x-axis. So Q4 here is going to be the quantity that maximizes revenue here. And what is the price that maximizes revenue? So you move up till it hits the demand curve, and you get P3 here. So what is the revenue maximizing price? Well, that's P3. Okay, so using the labeling in the graph above, identify the price and quantity that maximizes attendance while still breaking even. Okay, so if it didn't have this qualifier with the idea of breaking even, well, it'd be really easy. It would actually be Q7, which should be down here. It would be Q7 right here. But unfortunately, the goal is to maximize attendance while still breaking even, right? So what you want to do is you go down the demand curve here, and it's where the demand curve and the average total costs intersect. Because in this case right here, what you're going to have is the demand, or the price right here times the quantity. That's total revenue here. Now the total cost is where the ATC and the quantity, you multiply that. And so when you subtract those two, you get no economic profit right here. So if the goal is to basically cover your costs, then the profit or the attendance maximizing quantity while still breaking even would be Q5, and the attendance maximizing while still breaking even price would be P2. So you have a price of P2, and you have the quantity of Q5. So that's the whole idea in terms of stadium entrance. If you want to get as many people out there, but at the same time maintain some fiscal responsibility, that would be the price that would be optimal in that case. So assuming the existence of an opportunity cost at P2, indicate whether the stadium's accounting profits would be positive, negative, or zero. And here's the kicker. You want to explain why. So if this is a 2-point question, make sure you answer the first part, because you have a 1 in 3 chance here. You have 3 different choices. You have positive, you have negative, or zero. And then the second one, you get the second point for explaining why. So try to figure out, okay, what is this actually asking for? So let's take a look at P2 here. All right, so P2 here is a situation in which there's no economic profit, and that's what was established before. So if the ATC, so you have a profit. Profit, again, this is economic profit, or profit equals the total revenue minus total cost, right? So basically, the economic profit is such that we don't know the total revenue, we don't know the total cost, but we know the total revenue equals the total cost. And if that's the case, then the economic profit equals 0. Now, how do you find, what's another equation for economic profit? Well, you have economic profit, econ profit, equals accounting profit minus opportunity cost. So what you have here is, we know that this is 0 equals, and we don't know the accounting profit, but we want to know if it's positive, negative, or 0. So we want to know 0 equals accounting profit, minus opportunity cost. Now, one thing we do know here is that the accounting profit is positive. And we know the economic profit here is 0. So something minus a positive is going to equal 0. So absolutely the answer is positive. Okay, so the correct answer is positive. And the explanation here, if you just use this equation here, economic profit equals accounting profit minus opportunity cost, this will give you the explanation point as well. And finally, we're going to take a look at reading a monopoly graph here in terms of elasticity. So this one is finally going to explain why I wanted you to draw the marginal revenue curve through the x-axis. I'm going to go a little in depth on why that's the case here. So when the attendance is Q1, what is the demand? Inelastic, elastic, or unitary elastic? And explain. Okay, once again, if you have a brain freeze here, if you have no idea and there's no way to figure anything out, you have a 1 in 3 chance. Either choose inelastic, elastic, or unitary elastic. Probably won't get the exclamation point, but might as well get that first point, right? So how do you decide? Well, let's take a look here. One thing you can actually do, even without a graph, is figure out, just from a common sense perspective, if prices are high, is demand going to be elastic or relatively inelastic? So just think about very high prices and people's willingness to pay for large ticket items. If prices drop for, say, from $10,000 to $9,000, then you would assume that demand is fairly elastic, because at high levels of income, a drop of $1,000 will definitely tend to have a change in consumer behavior. Whereas at low prices, when an item drops from 25 cents to 20 cents, then you might have very little change in consumer behavior. So it would tend to be inelastic. So just as a rule of thumb, if you think about it from a logical perspective, things on the left-hand side of the demand curve would be elastic, and on the right-hand side of the demand curve would be inelastic, and then right in the middle is unitary elastic. But we're going to confirm that by actually working out the example right here. So when the marginal revenue curve equals 0 here, well, at MR equals 0, you've maximized the total revenue here. Now, what you want to do here is you want to move up the demand curve, and this area to the left of the demand curve would be referred to as elastic, very price sensitive. Whereas to the right of the demand curve is inelastic. So the question here at hand is, when the attendance is Q1, is the demand inelastic, elastic, or unitary elastic? Explain. Now, the explanation is actually quite simple here. This is Q1 here. The Q1 is here on the elastic portion of the demand curve. So it is elastic. Now, the reason why there's several ways that you can explain that is that MR is positive, or another inexact way is the price is on the left side of the demand curve. And one thing is absolutely certain here. A monopolist here, so this is kind of a side thing, a monopolist will always, now when I say monopolist, I'm going to assume a profit maximizing monopolist, will always produce on the elastic portion of the demand curve, always, without exception. The reason why is that the profit maximizing output will be on the left-hand side of the revenue maximizing output. And again, we know that the left-hand side of the demand curve is going to be elastic. Now, here's the reason why. I'm a little short of space here, but let's assume that this is a total revenue here. So this is a total revenue here, and bottom here is also the quantity or attendance here. So again, you want to draw this total revenue chart right here. If you're operating here on the inelastic portion, so from this point here, if you produce more, the total revenue is going to go down here. If you produce, from this point here, if you produce, or if you lower the price when it's elastic, what ends up happening is that the total revenue will increase. And conversely, if you're producing on the inelastic portion and you raise the price, then the total revenue here is going to go up. Or if you're producing on this portion of the demand curve and you raise the price, well, then the total revenue is going to go down. So you can relate the monopoly graph to the elasticity to figure out what's going to happen to the total revenue. And so that's why I find it to be very helpful to draw the marginal revenue across the x-axis, because then you'll know the point of revenue maximization. And if you dot that up to the demand curve, this is a point of unitary elasticity or unitary elastic. And to the left-hand part, you have the elastic portion of the demand curve. And to the right-hand part, you have the inelastic part of the demand curve. And so if you're a monopoly and you're operating on the inelastic portion of the demand curve, then it is absolutely in your best interest to raise the price, because you'll generate more revenue and you'll also generate more profit. Thank you for watching educator.com.